Hey everyone, and welcome. Today, we're diving into something called the atomic kernel. It's a new way of thinking about software, designed to tackle a problem you've definitely felt, but maybe couldn't put your finger on: the incredible fragility of our digital lives. Let's jump right in.
I mean, you know the feeling, right? It's when your character in a video game just glitches right through a solid wall. Or when your phone and your laptop just refuse to sync up properly. Or, and this is the worst one, that split second of panic when your banking app shows a balance that makes no sense. These aren't just little random bugs. They're actually symptoms of a really deep architectural problem with how we've been building things online for decades.
So, what's at the heart of all this? Well, it comes down to a single, shaky idea: implicit trust. For pretty much the entire history of the internet, we've built systems that just assume the other computers they're talking to are honest. We assume their data is correct. But that's a pretty fragile foundation to build our entire world on. And as things get more complex, you can bet those cracks are starting to show.
And this slide really nails the difference. On the left, you've got the old way. It's built on assumptions and trust. This leads to what's called state drift, where two machines slowly, quietly fall out of sync. And when it breaks, it fails open, meaning it can spread that corrupted data everywhere before anyone even notices. But the atomic kernel, on the right, it's all about proof. There's no trust involved. And if anything ever disagrees, it fails closed. It just halts instantly. It stops the corruption dead in its tracks. Okay, so if that's the problem, what's the solution? It's actually built around this really beautiful and powerful idea: a software crystal.
And this quote just says it all. You know that tiny quartz crystal inside every computer? It doesn't actually do any math. All it does is vibrate at a perfect, steady rhythm. It's a universal heartbeat that every other part of the machine listens to just to stay in sync. Well, the atomic kernel is that, but for software. It doesn't think or process data in the traditional sense. It just oscillates, providing a perfect, reliable pulse that any app or device can observe to find the correct time, and therefore, the correct state.
The magic that makes this perfect pulse possible is a concept called determinism. And it's actually super simple. It just means that if you start with the same seed and you're on the same tick of that crystal clock, you will always get the exact same result, every single time, on any machine in the world. You don't even need a network connection. This is the key to finally killing off those maddening sync errors. And get this. This rhythm wasn't just some random number the engineers picked. It's derived from pure mathematics. The system's entire timing, this perfect 8-phase pulse, comes from the unique properties of the number 73. So the key here is that the system's heartbeat isn't a design choice. It's a mathematical constant of the universe. It's forced by the math. Now, to make sure the system is absolutely unbreakable, it stands on what's called the verification triad. Think of it like a three-legged stool. First, you've got mathematical proofs. This is like the system's constitution. The code has no choice but to obey the math. Second, you've got runtime gates. These are the police, constantly on patrol, enforcing those mathematical laws in real time. And third, you have replay locks. These are cryptographic receipts that guarantee the system's entire history from day one can be perfectly reproduced by anyone, anytime. Okay, so we've got this rock-solid, verifiable foundation, but how does that translate into something useful for the apps we use every day? Well, it enables something absolutely critical for modern consumer tech: unforgeable digital identity. And it all comes down to neatly separating the what from the when. First up, we have the SID, which stands for semantic identity. This is the what. You can think of it as the soul or the DNA of a piece of data. It's a unique fingerprint of the content itself. So a specific digital painting, or a document, or a 3D model, if the content is identical, the SID is identical. Forever. It doesn't care about time at all. But then you have the OID, or occurrence identity. This is the when. It takes that timeless SID, that what, and it locks it into a specific, provable moment in history. And the way it does this is brilliant. It cryptographically chains the SID to a specific tick of the software's crystal's clock, and, this is the key part, to the OID of the event that came directly before it. And this is how that chain comes together. You can see each new event, each OID, is a hash of the content, the time, and the event that came right before it. This creates a chain that you can only add to. You can't go back and secretly change event number 2, because that would completely break the cryptographic signature of event number 3 and 4 and every single link after it. It's like a line of dominoes. If you tamper with one, the whole chain falls apart in a way that everyone can see. All right, this leads us to one of the most radical and honestly one of the most powerful ideas in this entire framework.
It's a concept that is absolutely essential for protecting you, the user, from bugs and glitches. And the idea is this: your user interface is just an opinion. So the system is built in these distinct layers. Way down at the bottom, in those first few layers, you have the pure mathematical kernel. This is the absolute, unbreakable ground truth. Then, way up at the top, you have the UI, the thing you actually see and interact with. But notice what it's called: an advisory projection. It's just a suggestion of what the truth is. It is not the truth itself. And here's the golden rule: authority only flows one way, from the bottom up. A buggy application, a poorly coded UI, a visual glitch, it might show you the wrong information, but it has zero power, zero authority to change the actual state in the kernel. So your banking app's UI might freak out and display a zero balance, but it can never, ever actually change your true balance because that truth is locked down tight in the mathematical kernel far below it. Okay, so let's tie this all together. We've got this perfect clock, an unforgeable history, and a system where the truth is protected from buggy apps. What does this foundation actually let us build for ourselves as regular consumers?
Well, it means we can finally build digital worlds that are as reliable and solid as the physical one. Imagine glitch-free games in metaverses where objects have real permanence and don't just clip through each other. Think about a smart home where you plug in a new device and it just works. No complex setup, no passwords. It means we can have digital art and official documents that are provably authentic and immune to forgery. It creates what you might call byte-stable realities, where things like your bank balance are always correct because they are mathematically proven, not just blindly trusted.
And that really leaves us with a final, pretty critical question. As more and more of our lives are lived online, in this world of increasing digital chaos, moving away from a fragile foundation of trust to a robust one of mathematical proof, it starts to feel less like an upgrade and more like a necessity. So the real question isn't if we can build on this kind of foundation, it's how much longer can we afford not to?